Hello, my name is Ian Watson, and I am a Director Emeritus of the American Membrane Technology Association, or AMTA. The interview you are about to see is the 25th in a series which we call Chats with the Pioneers. AMTA is a technical association that was founded on the advocacy of the use of membrane technology for water treatment, from wastewater reclamation and reuse to desalination of seawater. The heart of this technology is the membrane itself. About 3 years ago, the board of directors of AMTA decided that to preserve the history of membrane and membrane systems development, the association should initiate this series of chats with the pioneers, with those responsible for launching what is now a technology in use around the world. AMTA is making segments of these chats available on its website so that new generations of engineers and scientists can understand the efforts of these pioneers to help solve some of the water issues facing the world today. With me for this session, number 25, I have Mr. William Conlon and Dr. Robert Carnahan. I've known both of these gentlemen for a long time, and they are truly pioneers in this industry. Bill, I'd like you to start, if you would, by giving us a little bit of background. I know that you were involved in one of the earliest RO plants anywhere. So could you give us a little background, your education and experience?
I graduated from Florida International University School of Technology in 1974. Prior to that, though, I had a career in water treatment, about 14 years in the operation of water and wastewater treatment plants in about 5 different states. And after that, I had the opportunity to go to work for Post Buckley, Shoe and Jernigan. And in 1971, Post Buckley was the first to apply membranes to a municipal field on a brackish water plant in Ocean Reef Club. And I got to be the project engineer on that job. And I found membranes so fascinating that I've made it my career to date. But things were a lot different then. In those days, we had 4-inch elements. We operated at very high pressure, 600 psi, on a brackish water about 2,900 TDS. And we had steel vessels, which would peel. They were epoxy lined, and then there'd be a holiday and corrosion would get behind it, and that would foul the membranes. But it was a learning type deal operating that plant. But yet there was advancement took place so fast. Within a year, we had 400 psi DuPont elements in there, hollow fiber, which was, I guess, the first use of hollow fiber for a municipal type plant. And shortly after that, I just kept working in membranes because they fascinated me. I was a designer of the first low-pressure plant, 250 psi, in Venice, Florida. And there we had a lot of fouling problems because we used sodium hexametaphosphate as our anti-scalant. And operators, would make up a big batch of sodium hexametaphosphate, and in the Florida heat, it would revert to orthophosphate. And in 24 hours, we would have no control over our calcium sulfate, and we'd foul the membranes. So all of this caused me to take an interest in other chemicals that might do the job. And I was riding up and down in the elevator with the state toxicologist for Florida, and I asked him one day, would it be all right to use cooling tower type chemicals for the control of anti-scalants for the control of scaling? And he said, well, I'll take a look at it. So he did, and I pilot tested it, and that was the first use of anti-scalants. We got the approval. It was Flocon 100. You remember that, Ian?
Yep.
And so now a lot of people, that's their main business. And shortly after that, I was involved with a project in Venice where I had a long way to go to the Gulf to get rid of our brine. And I got the bright idea that we should use deep well injection. And so that it turned out we did a study, and it was cheaper to do the deep well injection than to go all the way to the Gulf with a pipeline. And so that was the first use. And then we shortly after did a second one. All of this while I was at Post Buckley Shoe in Jernigan. In 1977, I left PBS&J for a short period of time, got married, and went on my honeymoon to Saudi Arabia to put in the first seawater RO unit in the world in Jeddah. I worked on some of the preliminary chemical treatment design in San Diego with Gulf, Roga, and then went to Saudi as a site manager for about a year. And that was quite an adventure. I could write a book just on things that happened to me in those days. Then, when I came back, I was involved in a concept that Paul Culler and Stu McClellan had at Basic Technologies called membrane softening. And a fellow by the name of Herman Conrad and myself designed the first nanofiltration plant at Pelican Bay Improvement District in '78. And so this is a very interesting field, and it just keeps on going. Pilot tested ultrafiltration before anybody was thinking about it on surface water in Brevard County. Later got a chance to put ultrafiltration in front of RO at Shamu's tank in SeaWorld, and that was a reverse osmosis plant. We reduced the TDS and threw that away as the brine, and took the brine and put it back in Shamu's tank to concentrate the artificial seawater. So you might say that was the first time ultrafiltration was used in front of seawater type RO unit. And now in Kuwait City, while I was at Doosan, we did the first real big plant with ultrafiltration and DAF followed by ultrafiltration, and that seems to be the best treatment now, in these days at least. So I could keep on going. I don't want to take all your time and all the things that I've been involved with, but I've been involved with 200 projects in about 40 countries, and it's been fun.
That's good. Thanks, Bill. Bob, you have a long and varied career, part of it involved with membranes, but
Yes.
tell us a little bit about the whole thing.
Okay. Well, I was in the service. In 1959, I was at Fort Bragg, North Carolina, and from there went through numerous other facilities to include working on high energy accelerators and that. My exposure to membranes came early in 1965 timeframe, when Dick Schmidt, who was the director of the water division of the Mobility Equipment and Development Command with the Department of Interior, started looking at membranes, and membranes from the standpoint of being cellulose acetate, and of course hydrolysis problems with that. I didn't really get involved in membrane work as far as research and development was concerned until about 1973, when we worked on what was known as the Must Hospital system. It was a system set up for surgical, to treat waste from a surgical hospital. It took the laboratory waste, the shower waste, the mess hall waste, the scrub room wash down water, put them all in one pot, and they said, here, clean it up so we can drink it. We never got there, I can assure you of that. But we had some very interesting processes, and membranes were part of it. I then went down to the Mobility Equipment Research and Development Command, Corps of Engineers group, and got involved in treatment of wastewaters and water. And that's where I got involved in being the project officer for the 600-gallon-per-hour ROPU that the Army needed at that particular time. The Army had basically a distillation system that was would produce 150 gallons per hour of water. They knew they needed a minimum for the troops of 600 gallons per hour per battalion or regiment at that time. And so we got tasked with the problem of developing a unit for the Army, particularly for the airborne operations. Well, as an engineer, you're looking at water flow and membranes, and then somebody says, what if we decelerate this at 24 Gs? Well, look out, here it comes. And what we did is we were able to put together a small unit, 600 gallons per hour unit, that had essentially a configuration or a footprint that was 250 inches long by 96 inches wide by about 111 inches high. And you say, well, what about that? Well, the Air Force does not like you to push something out the back end of their airplanes that take the doors with it as you're flying along. So those were the conditions that we operated under. We were able to put together a unit that included basically a pretreatment system, which was the raw water pumps. We put together also the process that we needed to produce sufficient water for the troops, and that was basically a filtration system. It included chemical feed, it included the use of coagulants, and then membrane. And what we were able to do was go to commercially available contractors and take their particular project, or particular equipment rather. For example, a sand filter. We used a multi-element sand filter. We were able to modify that to get it within this envelope we're talking about to throw out the back end of an airplane. And we were able to do that. The other reason was that there wasn't at that time anything like as conservative as the membrane filtration for pretreatment. So you were stuck with what are you going to do for pretreatment, and what are you going to do to actually make a water with low turbidity, low colloids in it that would not foul immediately the membranes. And this we were able to do, and we also tested this unit on chemical agents. For example, sarin, VX, BZ, which is a hallucinant. We were able to treat those wastes and produce a product that would be, with a post-treatment carbon column, the water be able to be drunk by the troops. That was basically my career in working in the Army with membranes. I retired and accepted a position at University of South Florida as a faculty member, and brought some research with that so that we could continue to look at what were the problems associated with membranes. And basically, the idea of going from hollow fine fiber to spiral wound configuration was ideal for the Army. It may not have been ideal for other applications and commercial application, but you have to keep in mind, what did the Army have to do? It didn't have to be really have any superior efficiency. It just had to be able to move into the area and provide adequate water for the troops to drink. And this is what we were able to accomplish in the Army. We took that with us and built a research program at University of South Florida on membranes. And we collaborated with Central Florida and their faculty. So that basically, and I've worked back and forth in the areas of support for different towns. For example, Dunedin, the city of Dunedin, has a membranes plant. They allowed us to come in and do some of our research there, and it made things much easier for us, really.
And since you retired from the university, you're still working, but you're working now more on the waste side, I understand.
Yeah, I am working on the waste side. One thing I haven't tried the membranes to have tackled yet is if you take dairy manure, what happens to it when you try to treat the water with membranes? It's a difficult task. It really is. You're talking.
I have a story to tell you about Fort Belvoir and some work that we did there years ago as well. So remind me to do that.
Okay, I will.
So Bill, when you, thank you, Bob.
Okay.
Bill, when you saw that first membrane plant, you were fascinated?
Oh, yeah.
And so was I. Isn't that funny? And we've both been doing it ever since.
Right. It's amazing. I just said this is going to replace a lot of drinking water technologies that are considered, the thing to do, and it's just going to be a whole new world.
That's right. That's right. That's right. Well, I ran across it first. Let's see, when was this? This was back in the late 60s.
Sanibel, wasn't it?
No, it's before Sanibel even. Oh. I did a study for the old Office of Saline Water in Montana. And we were looking at candidate sites that could benefit from using not necessarily RO, but also ion exchange or ED at that time. And I spent like 2 weeks driving around the state, and I was followed by a guy who worked for DuPont. And he had a little permeator in a suitcase. Every town we went to, he would set up in the parking lot of the shopping center, and he would make coffee with water that he had treated and water that was available from the faucet there. Mm-hmm. And he was the best salesman for RO I have ever seen in my life.
Well, that was.
I mean, the fact that he worked for DuPont is neither here nor there, but he was demonstrating what an improvement there could be just in the simple business of making coffee by using this technology. And I thought to myself, this is really neat. So,
that's a concept that was also used in Nevada, Missouri.
Yeah.
I worked on the design there of a low-pressure plant. There's an isocore of some 19 cities around there that have high TDS water. And so, but basic technologies went up there with a pilot plant and gave the people water for coffee. These people didn't make coffee because it would be so bad with the water. I think they drank only alcohol. But it turned out that they liked the water, and we sold it to the town council, and we got to design it, and it's fun.
And you, in that plant, you actually used energy recovery.
Exactly. That was the first time that anybody ever used reverse running
turbines.
I got 25% recovery with a 5-year payback using 2 Hayward-Tyler submersible pumps just running backwards.
Yeah. I visited. That plant's still running, I think.
And that was also the first new type turbidity meter. It was made right there in Fort Myers, where you and I lived.
Oh yeah, right. Yeah.
And that's still running.
Yeah.
And actually, I was worried about having operators there. I figured they were all Ozark Mountain hillbillies, but they turned out to be the best operators you could train, and they knew their business. They took it serious. I'd go back there, and everything was in tip-top shape.
Yeah. There still hasn't been a lot of activity in that area, but there are a few more plants than there used to be out in that part of the world.
Yeah, I was wondering why, all of the 19 plants or whatever that I identified didn't go for it.
Yeah, some of them have, and then they've got them out in, they've started to build some out in Kansas. Mm-hmm. I went to one in Hutchinson, which is the salt capital of the world, apparently. They've got big salt works there and a big museum you can go down underground and visit, see how they dig salt out. And they have an RO plant there in Hutchinson. It's a town of 60,000 people, I think.
The problem is inland like that. If you couldn't do deep well injection, how do you get rid of it, the brine?
They They built an infiltration gallery adjacent to one of the local small creeks
Yeah.
and got it permitted by the state of Kansas, so I guess that was all right. I think it depends a lot in which state you operate and how they interpret it, the MPDS rules.
Right.
So I think some
Missouri-
places are easier than others.
Missouri was easy to convince
Yeah.
the regulatory agency because there's so much documentation in Florida. I just got Glenn Dykes, who was with the DEP in Florida, together with the guy in Columbia, Missouri, the head guy, talked to each other, and that solved it.
Yeah. Bob, when you were, I don't know if you were at Fort Belvoir at the time or not, but as part of that program, the 6-inch diameter element became a standard for the military,
Right.
which was not a standard in,
No.
in anywhere else. How did that come about?
Okay. What happened was that I was the director of the Water and Petroleum, or actually Petroleum and Water Technology Division at that particular time. And we had been working with the 4-inch element, and as you said, there was no 6-inch element at that time. And we were trying to figure out how we were going to deliver this water. Well, it so happened that what happened, I had put together just a brief flow sheet. And the idea was that we needed larger diameter membranes and we needed to get away from centrifugal pumps for high pressure. So we went to essentially plunger type pumps so that we could control the filtration rates within it. And then I talked to Bob Riley, and Bob was casting 6-inch elements for Jetta at that time.
For Jetta?
For Jetta.
Huh.
And this was in 1970, about 1977, 78 period.
That's the project that you worked on.
Yeah,
that
right.
was
They
the
must have just got the award at that time.
Yeah.
That was the 8-inch element, so,
Yeah, but they
Well, you
went to 8-inch.
but Riley was rolling 6-inch.
okay.
And what we did is we went and got somebody to put together the pressure vessels, because the 6-inch fit well on the side of this thing when you consider the height you were limited to. And so we put in 4 pressure vessels that were 6-inch in diameter. And Riley was rolling elements for Jetta. And I called Bob and I said, Bob, can we get 8, 12, or 16 of these elements? He says, I can't give you one. And then I said, look, here's the situation. And the Army was sitting there waiting for elements to be delivered. And Bob gave us, out of his batches, he let us come out and select the number of elements we needed, and we went to 6-inch. Well, then the Army decided, and rightfully so, they needed a 3,000 gallon per hour unit, and there they went to 8-inch elements. And so you have this 600 gallon per hour unit sitting down there with a no-name configuration with a 6-inch pressure vessel and elements. But he rolled those elements for us.
Yeah.
And then they were standardized for the military.
Right. Right. Yeah, and then the bigger unit went to 8-inch, because I remember
They went to 8-inch, yeah.
when I first went to hydronautics, they were building some of those for
Right.
the Army, I think.
The unit that the Army currently has at 1,200 or 1,500, it's using 8-inch elements, and it's also got essentially microfiltration as pretreatment.
Right.
What
Well-
were the vessels? I wonder what the vessels were made out of.
Who made the vessels for you?
But it was UOP that made the pressure.
And they're
vessels.
fiberglass vessels. Yeah. 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 You had a story that you wanted to
Yes.
relate about that?
On the first seawater unit
Uh-huh.
that Fluid Systems did, but the job that I went to Saudi Arabia as site manager, they used the first 8-inch fiberglass vessels. They were made in Canada, But at that time, we didn't have the technology, I guess, to do the advanced end cap, securing the end caps the way we do today, which are very secure. They would drill holes in the bell of the fiberglass vessels, and they would get bolts that were half threaded, and the other half was plain, and they would super glue, put them in with super glue, and then put the caps on there. Now, we were operating at 1,200 PSI in Jeddah, and if we had laborers, foreign laborers, and they were told not to torque it, tighten down the nuts more than 25 foot-pounds, and they would get carried away, you know, and the bolts would come loose, and we started to have end caps blowing off at 1,200 PSI and going right through the building. So a very dangerous situation.
Yeah.
We basically had the same thing.
Yeah.
Yeah.
And Toyobo, some of the early pressure vessels from Japan had that same type of configuration. You actually had bolts sticking out of the bell, and you just bolted the end plate on there.
I kept in shape by running real fast past the ends of it.
That's an interesting
The
story.
generator blocked them coming off the back end of the 600, so they only had one shot at you if you went across the front.
Actually, many years later, I was doing some work in Jordan for the Ministry of Agriculture and Water, visiting all these little villages along the coast of the Dead Sea, Jordanian side. We went to this one village. They had this brand new butler building sitting in the middle of the village, maybe 40 houses, something like that. And inside this butler building was a ROPU unit, 6-inch.
Right.
And they had acquired it somehow through USAID, but they didn't know how to hook it up. And they didn't have enough power in the village to run it. So they were trying to figure out how they could get a generator to run it, which I guess is how they did it in the field, right?
Right.
I said, how did that
you
get
know,
here?
that generator, there was a 30 kW generator that was on that unit.
Yeah.
It ran at about, once you got the system up and running, it was about 11 kW, but you needed the horsepower to get that thing to roll.
It was an odd place to find a piece of U.S. Army equipment sitting. So how long did you stay at Fort Belvoir?
Fort Belvoir. I was there from, let's see, I was there 4 years. That was the longest assignment I had in any one installation.
Were you involved, and this would have been when? What years?
What years?
What years, yeah.
It would be in the 64 time frame to 1979, 80, because I retired in 80.
Okay.
And
so you retired from Fort Belvoir?
No, I retired from Fort Detrick. I was sent up to the environmental research lab up at Fort Detrick.
So I worked on a project. I worked for an engineering firm in Maryland at that time. And we worked on a project for Fort Belvoir, which was for a barracks program that was totally self-contained.
Yep.
So it had total energy units, it had recycled wastewater, and so on. Do you remember that?
Yeah, well, there was a time frame when they were putting this together where they were going to recycle everything, and that's where the Muss Hospital got involved, and that was the barracks, and that type of configuration was left up to the people at Belvoir to work on, and it was in the time frame of late 70s, early 80s, I think, because I was on the reason I say that, I was already at University of South Florida when they called me and asked me to come up and talk to them about the potential project, and so.
Yeah, it must have been, as I moved to Florida in '77, it was shortly before I left that area, so that would be that
right.
way.
So that's the right time frame. That's when finally, I think Dick Schmidt, before he retired, had convinced people in the military that the membranes were the way to go. We did some work with ultrafiltration on shipboard waste, bilge waste. And the interesting thing was that the United States Army had more vessels than the United States Navy. They were just shorter. So, you know, you had the same problem. Guy comes up, throws a rope over to you on the dock and says, "Where do I pump it?" Well, you may not have a place to pump it. That's the problem, and that's what they were concerned with.
Yeah, as part of that program with the barracks, we looked at, you know, internal reclamation and reuse of sewage for drinking water.
Right.
And so we had some work done by the Manned Space Flight Center in Houston, who at that time was starting to look at the problems of recycling wastewater in outer space. So they attempted for about 3 weeks to actually get some separation for us on primary treated effluent, and they never could do it. So we just said, no, I don't think that'll work.
Well, that's really what we came up with a problem with in the MUFS hospital system, was that we could not. I mean, here you had a water that was a chemical photographic wastewater. You had scrub down water from surgeries. You had shower water. It just doesn't separate, and it never gets to the point where you can truly get a good cut at it with membrane.
Yeah. Now, Bill, you were in Saudi for a year, and when you finished there, did you go back to Gulf, or did you go back into the consulting business?
I went back to Gulf just for a short period, kind of debriefing, and then went back to work for Post-Buckley Shoe and Journey. And Mr. Buckley, who was the guy that really started the membrane stuff for Post-Buckley, said to me if I ever wanted to come back and want my old job back, I could have it. So I took him up on it.
Yeah. And then how long did you stay there?
I was with them a total of 18 years.
Then I recall you went to Montgomery Watson. Did you do that straight away, or did you go somewhere else first?
No, I was with Stone and Webster.
Stone and Webster, that's right.
And,
That's right.
I managed the old DSS group.
Yep.
Jeff Hart, and a whole bunch of others,
Yep.
Kurt Kiefer, and Bruce Watson was there at the time,
Right.
and Don Hornberg. But Don Hornberg left, and they made me put me in charge. And then later I went to New York City to work on some big sewage problems for Stone and Webster.
Which did not involve membranes.
No, centrifuges. Big centrifuges for 14 of their treatment plants.
Yeah.
But I have an interesting story about generators, or generator power. Did you were mentioning that?
Yeah.
The first seawater RO plant in Jeddah, each skid was powered by its own power generator system. And the reason was that the Saudis, in case of war with Israel or whoever, they could take these skids and move them anywhere at their military sites.
So they essentially, and that was, what, a 3.6 MGD plant, as I recall?
Oh, you know.
Something like that.
No, it was...
How many trains did you have?
So there must have been 10 or more.
So each one they could pick up.
They could pick it
kind of
up.
like a rope.
Well, sort of like a giant rope.
Yeah, that's right.
Giant
That's
size.
right. Isn't that interesting?
But I don't think they would have had time to take and move them in case of war. It would have been too much trouble. They did things a lot different than they. You know how they chlorinated at the all the plants next to it were thermal plants, and they would just take a chlorine cylinder and run a pipe from the chlorine cylinder into the seawater, and it would be all the gas would be coming up out of the water around the site. And I was worried about our membranes, you know, with the chlorine vapor and all, that might damage these membranes.
Yeah.
So I told them how to. I told them first. I introduced them to chlorinators. Showed them what a chlorinator was.
Sure, what a chlorinator was. Yeah. Yeah, that was an interesting project. That was I guess, the first use of the PA 300 membrane, wasn't it?
Yes.
Yeah. That Riley spent so much time trying to develop.
That was the last EPC contract that Fluid Systems did.
Right.
They did one. Well, I don't know if they did others before that, but just that internationally, that was the only one.
Yeah. Yeah. Yeah, and that was a requirement, I think, because they had the bidding shortly before the 1977 NUISIA conference, which was in San Diego, which is, as you know, NUISIA was AMTA's predecessor.
I was a member.
You remember. And I think, I can't remember if it was Permuted or Polymetrics who was the other finalist with the B10 membrane.
I don't know, but shortly after that project, right after JETA, Polymetrics did Yambu.
Right, right. So it may have been Polymetrics that was the other bidder.
Probably.
And everybody was really surprised because, you know, the SWIC awarded it to Gulf with, you know, a brand new membrane that nobody had really ever used before in an application. It had been tested, obviously, but
Prior to
as
that,
opposed to the B10, which was in existence in 3 or 4 places already in Saudi.
I think
So,
prior to that, everything was cellulose acetate, right?
in the spiral, sure. Yeah, yeah.
Oh, that's how the first nanofiltration membrane was made. It was partially hydrolyzed.
I remember Pelican Bay.
yeah,
I
that was
remember
a
that. And then they
partially-
built another one at Pheasant Run over here on this side somewhere, West Palm Beach.
Maybe so, I don't know.
Same approach. Yeah, yeah, yeah. And Paul, as you mentioned, Paul Culler and Stuart McClellan really were the ones that came up with that
It was a
concept.
basic technology concept number 5 or something
Yeah,
like that.
yeah, that's right.
And I saw the drawing of that, and Herman Conrad and I said, let's do that, because we had a 1200 TDS groundwater, and we couldn't use that for drinking water. So we put in the nanofiltration plant, and we also had a wastewater plant, took that effluent, put it in a lined pond with the brine, and then took some makeup water we got from other groundwater supply, and that irrigated the golf course there for 10 years.
Right, I was there for a long time.
Yeah.
I remember that. What did you do for water in Vietnam?
Vietnam? Surface water was primarily what they did, and some well water in upper
And
two
what
course
sort of
north.
treatment did you have?
You had what was the old ertulator.
Ertulator. I haven't
Yeah,
heard that
ertulator.
word for years.
And that essentially was this coagulation.
Yeah.
And it had an upflow clarification, and it went to then filtration.
Right.
And that was what the Army had. Then they had, like I said, 150 gallon per hour distillation, thermal compression distillation units. But when you started looking at that, particularly with chemical agents, because of the vapor pressure of the chemical agents, that there was carryover of sufficient
into the steam and the
contaminant
condensate.
that you couldn't use
Yeah.
it. So.
And that was driven off engine block heat, wasn't it? Isn't it
No.
somehow connected to the, well, it was a diesel engine generator
Yeah, that's
that
what
was
it was.
attached to it.
Yeah, right.
Didn't you get some of the heat from the block?
Heat from that, yeah.
Yeah, that's right.
Right.
Yeah. Yeah. Were you not worried in Vietnam about, with the ertulator system, which is not really a barrier, that, you know, somebody would dump something nasty upstream?
Yeah, that was a problem. But if you looked at what was set up in Vietnam, the tactical units had the ertulators. So they would go out and find some type of source of water and try to treat it. If you had a permanent base camp, then you had essentially post-engineer type operations where they constructed the water treatment equipment. And for example, up at Phuc Vinh, I actually found that where we had an old water supply, it was related to the French occupation there. They had actually cast in concrete a venturi in the center of the separator to get sufficient velocity and mixing and that. And so we'd take advantage of any type of facility like that was available, retrofit it, and use it as a water supply for a larger base camp operation.
That was probably designed by Mr. Degremont himself.
That's probably true. But also they could lift in water bladders, water buffaloes and that, so, yeah.
Bill, you mentioned when you were making your opening remarks that you had done some early work with UF ahead of RO.
Yes.
Where was that?
That was SeaWorld in Orlando.
Oh, that was for Shamu's system.
Shamu's system.
Yeah, okay, okay.
Yeah. And we had some interesting problems. I sent the engineers out to get samples. I said, please get me composite samples of Shamu's tank. And they didn't. They went and took grab samples. So the water showed up cleaner, and they didn't take any samples after Shamu was fed, and all that oily fish got in the water. So here there's a finished unit there working and plugging up with all this oil.
And that was built by Basic Technologies, right?
I believe so.
Yeah.
It's been a while.
And what UF did you use there? Do you remember?
It was, yeah, DSAL's spiral one.
Oh, spiral UF. Yeah.
DSAL, that
okay.
was either G20 or G10,
Yeah,
one of
right,
those.
Right.
Anyway, what we did was then I found out when the feeding periods was. I put it on a timer, and I would have it, the unit, the control valve closed completely, and just at zero recovery, have the membrane wiped clean, and then put it back in service again, and that worked.
Yeah, that's good. That's good. And you did some UF work on Lake Washington?
Yeah, Lake Washington, we did a study with G20s and G10s. At that time, they didn't have any hollow fiber that were large enough that could be used in a municipal application.
Yeah.
But
I think I remember hearing you present a paper on that somewhere.
We did, yes.
Yeah. So you went to Montgomery-Watson, and then you went from Montgomery-Watson to CDM, and you went out west, right?
I went to CDM after I ended up in New York working on wastewater
Right.
with Stone and Webster, and went to CDM as a client officer in Ontario, California.
And did you move to California?
Yes.
Yeah. And how long were you out there?
4 years. Yeah. It was very nice, very good experience. And from there, I went to Rust in Wisconsin.
Right.
As their border practice leader,
Right.
vice president. And they got bought out by by EarthTech. And then EarthTech bought AECom. But I left there and came to Tampa, and I've been in Tampa ever since with PB and with Doosan.
Right. How long were you at Doosan?
Several years.
For some reason, I don't remember you being there. I know you were there because Ali told me you were there, but
Right.
I just don't remember you being there. It must be a blank spot in my memory.
I left PB for a little while. Just Ali said he wanted me to work for him.
Right.
So I worked for him for a couple of years as senior vice president and chief engineer. And then went back to PB. They had my old office waiting. And
Now, did OJ work at Doosan while you were there?
yeah, OJ came on board,
okay.
and then he went to Saudi Arabia, and from there he ended up working in Saudi Arabia.
Yeah, he was there 3 or 4 years, I think.
Yeah, I think with Aqua Power.
Yeah, right. So you think, is there anybody that you've run across during your time in this business or in your career that, I mean, you saw a membrane and fell in love and that was it, but Bob, is there anybody that actually you felt influenced you in any way in the membrane side of the business?
Okay, if you're talking about the water side of it, yeah, Dick Schmidt and then Bob Riley, the group out at Fluid Systems, Dave Furukawa, they all had an influence on my staying. Probably the strongest influence I had, though, as far as membranes was concerned, was my commanding officer who said, "Get it done." And no, Colonel Hughes, who was an exceptional commander, was very supportive of the program. So those people I think influenced me more than anything else as far as going into the field of membrane technology. I had some exceptional students who I think influenced me, taught me a lot while I was supposedly teaching them. They were teaching me just as fast as I was teaching them. Savannah Good, Marilyn Barger were two people that really did exceptional
And
work.
several of your graduate students actually are now in the business.
They are, yeah, right.
Yeah.
And so, you know, the university environment was great for me, and that, as I said, the students seemed to teach me more than I taught them.
Yeah,
So.
yeah. And the one student that both you and I know very well,
Right,
got his doctorate with you,
right,
went into the business,
right.
and is now doing something else entirely.
Yeah,
And I'm not quite sure why, but
I don't know. 'Cause,
I
He-
mean, he was always very interested in membranes.
Yeah,
And
but he was a curious guy.
very curious.
And you know, he would come in with some ideas that you'd say, wait a minute.
Yeah, of course, we're referring to Miles Beamgard,
Right.
who left, I guess he got his doctorate, and he went directly to 7 Seas, I think, didn't he?
Yes, he did.
And he was
Yeah.
there for some time.
Yeah,
Very smart guy, very smart young man.
I think the last I talked to Miles, he was asking about his PE license, and of course he's a registered engineer now. So, but I don't know. I haven't heard much from him since then.
So when you went to work for John Buckley, who I didn't know very well, but he was
Partner.
very influential in a lot of people's careers, I think.
Yes, he was.
Did he keep you? I mean, he assigned you as the project engineer on the.
Yeah.
And did he encourage you to stay involved in this
Oh, yeah.
technology? He
Yeah,
did.
I worked very closely with him up until the time I left the company. And still would like to keep in touch with him, but haven't had a chance to run it with him. But people that were influential in my career, were the first exposure on the first unit in Ocean Reef Club was Charlie Hull and Carl Hickman,
Ah,
if you know those
Yep,
guys.
yep.
And then later Jack Luce and Al Riedinger
Yep,
and Dr. Seymour Kremen.
yep.
And all of these old timers.
Yeah. Yeah,
they were helpful
we've
to me.
interviewed some of those who are still with us. Of course, Seymour left us quite a while ago.
Yeah.
And so did Al.
So did I, yes.
But we managed to interview Jack Luce shortly before his passing,
Yes.
so that was good.
Did anybody ever find out why Seymour went and got his degree in law along with his PhD?
No, I don't think anybody ever did. But Seymour was an interesting guy. I
Yes,
mean,
he was.
After he retired from Fluid Systems,
Right.
Jim Bartlett hired him at Hydronautics, and he used to come up once a month.
Right.
And he and I used to have dinner. And I probably learned more about membranes having dinner once a month with Seymour for a year or so than I've learned anywhere else.
Yeah.
I mean, the guy was an encyclopedia.
He really was.
Yeah.
Another fellow I remember is Nussbaum.
Izzy was great.
Really.
Izzy was great, yeah. Well, we could probably sit here and talk a lot longer, but I think we've used up our allotted time pretty much. I want to thank you both for coming.
Well,
I've known you
thank
both a long time, and it's a real pleasure to sit here and chat about some of the old days with you. Thanks very much.
Thank you.
And I learned some new things about you, Ian. I didn't know.
Yeah, right.